So subject to is done now, right? So what should be the max or min or whatever you want to call it? Huh? How do you, what is the problem that you will solve? Hmm? What is the problem? Any guess? Do you think there is a unique solution or a unique separating hyperplane? No, right? There could be uncountably many. Forget about finite, right? There could be uncountably many, so many hyperplanes in between, right? Yeah. So, what is the problem that you will pose so that you will get at least recover one of them? Hmm? Hmm? Okay. Now let's go back. Again, it depends on the physics of the problem or the data that you have. Which is the best hyperplane? Whatever, quote unquote best. How do you come up with the best? Right, roughly, right? So suppose I take this and I keep moving. Okay, so I keep moving here. Do you think which one is better? The former, right? Black one. Do you think this is good? Still, see, these are all feasible solutions because it separates the two. But what might happen is, one of these data point right here, you would have observed this data point because of some noise, right? But in future, you might get data points belonging to this, which is somewhere here, right? Then you'll misclassify, right? On the other hand, what is the worst possible thing to happen? Something that passes through this, right? On the other hand, what is the worst possible thing that can happen? Something that passes through this, right? So, how do you find so-called best? See, separability is easy, right? So you should be able to find some AB. There are uncountably many ABs. One of them will work. But as an engineer, you have to find the best one, right? So that's where the objective comes into picture. So what do you mean by best here? Hmm? What do you mean by that? What do you mean by that? Of course, roughly you are right, but how do you pose that as a problem, right? Some function you have to say. The function should be such that it is moving closer to the other data point. The function should, if you are maximizing, then the function should go down, right? If you move to this side, also it should go down. Somewhere in between, you should have a minimum, right? That's the best hyperplane you can find. So, how do you find that hyperplane? What do you think the solution is? So what kind of hyperplane one should find, or what is the constraint on A and B, right? Any idea? Hmm? Huh?